Hello, and today's purpose of the day is I can add and subtract rational expressions. Please take a moment and work on the warm-up. Please find the LCM, which stands for least common multiple. Number 1 of 12 and 15, and number 2 of 7 and 20. Great job! Let's go through these examples together. So find the LCM of number 1, 12 and 15. Well, I'm going to break down 12 and find the prime factorization, and that would be 2 times 2 times 3. Then if I break down 15, that's 3 times 5. So what the two share in common is just a 3. So I only need to write 3 one time. But then 12 has two 2's that need to be multiplied for the LCM, the least common multiple, and then the 15 has a 5. So now I must multiply 2 times 2 times 3 times 5, which equals 60 for the LCM of 12 and 15. Number 2, 7 and 20. So if I find the prime factorization of 7, that's just 1 times 7, and 20 would be 2 times 2 times 5. So they actually share nothing in common, so I just actually have to multiply all the numbers together, which is just 7 times 20, which is 140 for the LCM of number 2. Before we go through a couple examples, let's look at the new vocabulary. So LCM, as you know, stands for least common multiple, and LCD, which we'll be introducing today, stands for least common denominator. So this example here will help us today. How would you add these fractions? A over B plus C over D. Great job! We do need a common denominator, so between B and D, what does the other fraction need that fraction has? Well, if we look at A over B, what B is missing is the letter D, so I must multiply by the letter D over D, which then would be AD over BD. Now I will add to that, the second fraction needs the letter B, so I'll multiply by the letter B over B because, again, the common denominator of B and D would be BD. So this would be plus C, or I should say plus BC over BD. Now I have a common denominator, so I'm allowed to add the numerators. So what I get here is AD plus BC all over BD. So just working with getting a least common denominator will be really helpful for today. So we are going to add and subtract rational expressions with unlike denominators. So we still need to make sure that we have a common denominator. In steps to unlike denominators, to add or subtract is 1, we need to find the LCD, the least common denominator. So if x plus 3 over x minus 5 over x plus 1, what is the LCD? You got it. Between x and x plus 1, it's going to be x times x plus 1, and I'll write that at the top. So if I look at this first rational expression, x plus 3 over x, what that needs to be multiplied by is an x plus 1. And again, in the numerator, I also must multiply that by that. And then the second rational expression needs just to be multiplied by x. So now I'll go ahead and multiply that through. X plus 1 times x plus 3, I'll just write down here, x plus 3, or let's write first x plus 1 times x plus 3, keep it in order, minus x times x minus 5, all over, now I have a common denominator of x times x plus 1. And we already actually completed step 2, which was multiplying both the numerator and denominator by the expression needed to get the LCD, which we did, and we rewrote right underneath. And then now we need to add or subtract. But before we can really add and subtract, let's multiply here this x plus 1 and x plus 3 and x minus 5. So x plus 1 times x plus 3 is x squared plus 4x plus 3, and again that was because we could use either FOIL or the box method, minus, and now I'm going to put this all in parentheses because if I distribute that x, I get x squared, and then x times negative 5 is minus 5x. So now I have to make sure that I'm subtracting both terms because I don't want to forget and have a double negative and miss that, or just forget that I'm subtracting both terms, all over x times x plus 1. So now if I look to simplify here, I have x squared minus x squared, so those actually cancel out. I have 4x minus negative 5x, which is chop chop, really adding, which is 9x. I have 3 minus 0, so that's just plus 3, all over x times x plus 1. Now let's look and see if we can factor out anything. And with the 9x and 3, I can take out a 3 and then get 3x plus 1. And now we're on step 4. Factor and simplify if possible. All over x times x plus 1. So now I look and see if I can cancel out any terms, and I can't. There's nothing that is the same that I could cancel out, so this would be my final answer. But it's always good to check and see when you factor if you could simplify out, because you never really know until you get into its simplest form. So this would be our final answer. Okay, let's go through another example. So we're still going to follow those same steps that we had on the other slide and make sure that we have a common denominator. So if we look at number 2, we have x plus 7 over x squared minus 6x plus 9 plus x plus 3 over x minus 3. So I'm actually going to factor this denominator here and see what this trinomial factors into, and that would be x minus 3 times x minus 3. So, and then this rational expression has one x minus 3, so a common denominator of x minus 3 and x minus 3, and then the other rational expression of just x minus 3 would be 2 x minus 3's. So the first rational expression actually is already simplified and done. I just need to multiply the second rational expression here by x minus 3. So when I do that, this stays as x plus 7. And now I'm going to add. Now if I FOIL these two terms here, I'll leave them as they are so we can see everything that we need to do, over x minus 3, and I could say the quantity squared. And now let's go ahead and let's FOIL here these two terms, and then we'll combine like terms. So I have x plus 7 plus, and then I have x squared minus 9 all over x minus 3, the quantity squared. So if I combine like terms, the x and x squared can't combine, but this 7 minus 9, those can combine. So I'll scroll up here. So what I end up getting is I get x squared, if I put this with highest degree to lowest degree, plus x, and then 7 minus 9 is negative 2, all over x minus 3, the quantity squared. Now let's factor the numerator because you never know if there's terms I can simplify. So x squared plus x minus 2, I need to find factors of negative 2 that when added together give me 1, are 2 and negative 1. So this factors into x plus 2 times x minus 1 all over x minus 3, the quantity squared. And it appears that no terms can cancel out, so that would be my fully simplified answer. X plus 2 times x minus 1 over x minus 3, the quantity squared. Thank you for listening. Please check Google Classroom or Schoology for more information. Have a great day. Bye.